Hey everyone, welcome back to Birendra's Java Lab, your go-to place to master Java step by step. In today's video, we are diving into one of the most important concepts in Java's concurrency toolkit, and that is executor services. If you have ever struggled with managing threads or wanted to execute multiple tasks in parallel without writing messy thread code, then this video is definitely for you. Okay, so let's get started without wasting the time. So as you can see on the screen, these are the notes I have prepared so that it will be helpful for you. Even you can pause this video and note down all the notes, or else you can just go to my GitHub repo, and from there you can directly download. I will be uploading all these notes and Java example codes. So we'll start with the basics to understand in more easiest way. Okay, so let me know if you have any doubts in the comment box. I'll be happy to answer all those doubts and queries. Okay, so first point, it is saying executor service is an interface in Java that extends executor. So executor is a parent interface that can be called as a factory class which having multiple methods available. Next, it is saying offering a high level abstraction for managing threads. That means you might have heard the word abstraction. It hides all the uh, logical implementation to create threads. You don't need to create any threads manually from your ends. Everything will be created or managed by executed services. And that we'll see how. So next, what is saying, instead of manually creating and managing threads, it allows you to focus on submitting tasks. So you just create the task or whatever task you have, you just submit. They have multiple methods to submit your task using like runnable task or callable. Okay, and this runnable and callable we'll be discussing later in this video in detail. It simplifies concurrency by handling thread creation, execution, lifecycle management, and shutdown internally. Okay, so everything would be or will be handled through this executor services. Hope this is clear. Now, the questions why we use executor service. So this is the definition about executor service. Now, why use, right? So in definition, we already covered this point about manual thread creation and management. Okay, so it will create and handle everything, right? Improve performance via thread pooling and reusability. That means it improves performance. You no need to create manually thread pool or no need to manage. You want thread pool, it will give you. Okay, so it's kind of having everything's managed through executor service. You want thread pool, just call these functions called fixed thread pool, how many number of thread pool you want to get it. So everything will be handled by executor service. Okay, we'll see that example as well later in this video. Handle task execution with better control and flexibility. You have lots of control. It's not like it manages, it does to give control. It gives you control to stop or to terminate your current running threads as well based on your requirements. Provide tools for tracking tasks, retrieving results, and handling exceptions. That means, as you saw this callable and runnable, as I told, I will be talking on this in detail later in this video. But still, for I will take this reference of this callable. When you submit your task using callable, it gives you object called future, which is nothing but the object which having all the results and all the details of your execution of your task, so that you can track, you can retrieve the results, and you can do many more with that future objects. Okay, now let's jump to core concepts of this executor services. So in core concept, as you can see, we have task, thread pool, and methods. If you see task, so what do you understand by task? Means anything that you can you have, let's suppose you have a employee object and you want to do some of the operations to modify your state. Then that if you have a list of employees where thousands of employees are there, or maybe more than thousands of employees, and you want to do some operations after retrieving from the DB, right? You want to modify based on their the fields. Sometimes what happens, you want to find out the result by combining few of the fields all together for the user services, for the UI, right? So in that case, what you have to do, so if you provide those tasks to the single thread, then it will take lots of time, right? And you don't want to stuck for 10 minutes of doing all these things. What you will be doing instead of that? So that is concepts called thread pooling, right? So where you can split your main task into multiple subtasks, and just send it to executor service, and it utilizes the thread pool to assign those subtasks into different threads, right? So that's a general task. It can be anything, any kind of task, right? So this task can be submitted using two ways. One is through runnable, one is through callback. When we call runnable, then as you know, runnable interface doesn't only having one method called run and doesn't return anything, right? So it represents a task that runs but returns no results. Correct. Callable represent a task that returns a result of type v and can throw exceptions. So example, you can see callable of string integer. So this v is nothing but a type parameter. So it can be any type. Okay. It can have the object like callable of employee objects returning employee sub details right after performing the task. Now let's go to move to the next point that is called thread pool. So what is thread pool? A set of worker threads reused to execute tasks. As I told, in case of employee object, where we have to split main task into multiple subtasks and assign to the thread pool. So all the threads available in the thread pool will be utilized to perform on these tasks. Okay. So that is what reducing the overhead of thread creations. And you don't need to create multiple tasks, multiple threads manually. So everything will be done through executor service, and which manages this thread pool. Okay. And one more thing I want to let you know here, like when you create when this thread pool gets created through executor service, let's suppose when you call a get thread pool of 5, and if two threads are being used and 3 is idle, so don't think like it will utilize your CPU or your memories. No, the idle threads have some lifespan of whatever duration you will provide. So after that, that will die automatically. That means when required, it will get called or will be in use. Other than that, it won't take any space of your CPU server or of your memory. Now let's understand the key methods in this executor service. As you can see, we have this method, and this side I have written the descriptions. You can note down, and let's understand first the submit functions. So this, as you can see, it's when you submit a task in this callable. So we can submit through runnable and callable as well. When you do it through callable, so submits a task and returns a future object to retrieve the result or check completion. So you can check the results that been returned, or you can see other behaviors also, like when does this completed, and all the status of your task, right? So in this submit using the runnable, as I told, like this doesn't return anything, right? But when you submit, so it returns a future object, but if when you call future.get, it returns null, as the result will be null, because this runnable, as you know, returns void. So this is fine. Okay. So let me know if you have any doubts here, because even many people get confused here, like how the animal doesn't return anything, then why this future object being returned? Because this is the behavior of submit functions. Okay, it returns, but if runnable doesn't returns anything, this feature won't contain, but it will have some basics information, like when does it complete, whether it is completed or not. Those details you can get, but as a result you won't get anything. Okay, right? Now let's go to the next functions called execute. So executes a task but does not return any result, fire and forget. So when we call execute, okay, that time you just call execute by passing your task and you forget everything. So task will get executed but you won't see anything like any results of completion or its status whether done or failed, anything like that. Now shutdown. Initiate an orderly shutdown where previously submitted tasks are executed but no new tasks are accepted. Okay, hope this is clear. Shut down now attempts immediately stop all running. That means, so let's suppose you had called or submitted 10 tasks, and immediately if you do the shutdown now, so what happens? So whatever task is being queue executed, that will is fine, but other that is in queue will be terminated as well. So that is what is saying. Attempt to immediately stop all the running and queues tasks and returns a list of tasks that were waiting to execute. Okay. Await terminations where you can mention your timeout and unit that waits for the termination of executor service within a given time frame. Right. So these are the few of the methods, and you will see each in the examples, right, to understand in a better way. Now let's move to types of executor service implementations. So as you can see, Java provide convenient factory methods through the executors utility class to create different type of executor services. We'll see one by one, right? So first one is single thread executor. So when the name itself is saying single thread executor, that means it gives you executor services which having a single thread. So it creates a single thread executor, execute tasks sequentially one after another. Useful when task order matters, like if you want to log something that time, or if you want to write file, so a sequential order, that time you can get use of this thread, right? And example, like if I say example, so this is the way you can create this new single thread executor through this executor framework. Now when you call this submit and you do, let's suppose this is logging, I'm saying sys out of task in order. So whatever task you have mentioned over there, so everything gets executed in order, sequential order. So in that case you can use of this one. Okay. Now second is fixed thread pool. Okay. So fixed thread pool is creates a thread pool with a fixed number of threads. Let's suppose you want to create threads of 5. So it will give you a thread pool of 5 thread which you can use as per your need, right? But so control the number concurrency executing tasks. Okay, so it will controls the number of concurrent executing tasks. So that means, so if you have task multiple tasks, so that gets executed concurrently. It's not like in a order, like let's suppose as a example I have say a bank with 3 counters, right? Even if 50 customers arrive, only 3 served at a time. So that means if you have created a thread pool of 3 threads, and if you have 50 tasks, so those 3 threads will be used to serve all those 50 tasks, right? And if one thread is taking more time and other thread is idle, so your task will automatically shift to another thread. So it like that it will happen. So it will happen all in concurrent way, right? And this is the way to create this new fixed thread executor dot new fixed thread pool of 3. In this case I have taken 3, and this is example if 10 tasks we have. So in test, if you see here executor dot submit, we are submitting this task for 10 times, and these 3 threads will get used while executing this task, right? This example we'll see one by one after explanation of this entire you know concepts. So the next is cache thread pool. So the name itself is saying cached thread, right? Create a thread pool that dynamically creates new threads as needed. That means you no need to mention anything when your task grows and requirements grows to perform heavy task. That time, so this is very much needed. So let's suppose if you want to perform, you don't know how many threads required, and there are some bigger tasks that to be performed. That time you can use cache thread pool. So automatically it will give you the number of required threads. as for the tasks. Creates a thread pool that dynamically creates new thread as needed. Reuses previously constructed threads when available. Suitable for many short-lived asynchronous tasks with varying load. Okay, that means you are not sure of the loads. Like sometimes it is less, sometimes high. So in that case, this is very much suitable. Okay, and the to get this new cache thread, so you can call this executor new cache thread pool, and you are good to go. Right, and this is the example. So hope this is clear, these definitions, and if you have any doubts you can just post your queries in comment sections, and I will see you in the next video with the coding implementations, and we'll understand more in detail how does that works here, and how to write the code. So I have already these classes, as you can see, I have already written, and I will explain how this executor service executor executors works, but it will take a long time. So better let's see in the next video. Thank you so much, and if you have not subscribed, please do it and share with your friends if you liked. Hit the like button, and also please share with your all the techie friends who can also can get benefited from this video. Thank you so much.